So now that we understand the importance in risk in decision making, we're ready to incorporate risk into the model of consumer decision making that we've already developed, our model of utility maximization. So here we have a choice between two jobs. A job that pays you $54,000 a year with certainty, and a job that has a more uncertain salary. 50% chance you'll earn $5,000 and 50% chance you'll earn $105,000. So the first question we can answer without any further modeling, which is which job would you take if you are risk neutral? So here we're introducing the concept of risk preference. Do we like risk? Do we not like risk? Do we not care about risk? Risk neutral means that we don't care about risk. So we simply choose the option with the highest expected value. All right, so what's the expected value of each of these salaries? Well, the first one is obviously you get $54,000 with certainty. The second, you got $5,000 probability, 50% plus $105,000 with a probability of 50%. So that gives me $55,000. So because the expected value of the startup job is greater than, that's 55,000, is greater than the expected value of the large company desk job, then you're going to choose the startup. All right, so now obviously not everyone would make that choice. Some people would choose the large company and some people would choose the startup. So we want to now incorporate a more diverse sense of risk preference into our utility maximization model. Okay, so now let's suppose that our utility function is equal to the square root of I. Okay, if you remember, this is a really simple way to get an increasing function with a diminishing marginal utility, right? So the slope is positive, but decreasing, becoming flatter the more we consume. And that was one of the fundamental assumptions that we made about utility functions in the first part of the course. Okay, so here's our utility function. And now we want to think about what is the expected utility of each job's salary. So now we're not thinking about expected value exactly, we're thinking about expected utility, okay? So how is that different? Well, let's try to draw the lottery here on our graph. So what's happening is that we could have an income of 5,000, which would give us some value of utility. We could have an income of 105,000, which would give us much more utility. Instead of thinking about just comparing expected values, we want to now compare expected utilities. So what is the utility of 5,000? What is the utility of 105,000? And then the lottery is some combination of those two values. All right, so if we now look at the expected utility of 5,000, that's the square root of 5,000, that's going to give me 71. And I've rounded a little bit here for simplicity. Okay, but that's okay. 105,000 gives me a utility of 324. And then, so we have a lottery with, so I'm going to call this L for lottery. The lottery with these two outcomes will have an expected utility at some point along this line. Why? Because, okay, here's my utility of 71. Here's my utility of 324. And what I'm doing when I calculate the expected utility is I'm multiplying those values times their probabilities. In other words, taking a linear combination of the two, right? So if the higher one is more likely, I'll be somewhere up here. If the lower one is more likely, I'll be somewhere down here. In reality, I'm in the middle, right? Because the expected value of the lottery is in the middle. We have a 50% chance of each. And so this point along this lottery line is going to give me the expected utility of the lottery, which will be 0.5 times 71 plus 0.5 times 324, which is 197. And you can see that that's different from the utility of the expected value. Okay, so the expected utility is different from the utility of the expected value. The utility of the expected value would be the utility from 55,000 with certainty, right? The utility of 55,000 with certainty would be the square root of 55, which is 235. Okay, so this is the utility of the expected value of the lottery. And you'll notice here that the utility of the expected value, certainty, right, is bigger than the expected utility. Risk, right? So both have the same expected value, right? If I have $55,000 with certainty and if I have $55,000 with risk. Here you can see that this utility function exhibits what we call risk aversion. Meaning that people don't like risk. Okay, if we compare two options with the same expected value, but one has more risk, it will give us less expected utility than the other options. People don't like risk. Okay, and we can model that pretty simply here in the context of our utility model by thinking about this concept of expected utility. Okay, so now let's go back to the initial question here, which is, what do you prefer? Do you prefer the job of 54,000 with certainty or the job with 55,000 and risk, right? So if we have to complete this by finding the utility of 54,000 with certainty, which would give us a utility of 232, which you can see is higher than the expected value of the lottery, which is 197, okay? So on a graph, right, I could put a 854 here, go up, and then I get 232, right? That's the other option in this problem. And you can see, even though it has a lower expected value, expected income, we have a higher utility from that, right? So here we prefer the desk job, right? The large company. That would be the answer here in this situation where we have this particular utility function. And you can see that really the reason, what is the reason that we get risk aversion from this particular utility function? It is due to that assumption of decreasing marginal utility. The fact that the higher our income, the lower we value each additional dollar. And so the potential gains here from the upside are lower than the losses from the downside, right? And so that's why we get a lower expected utility with this utility function than we do with just looking at expected values or with a different utility function. So we'll go through some other utility functions now that show some different risk preferences to see what they look like, but it's important to note how the assumptions about utility affect the value of risk and decision-making in the context of risk.